Hey there, students. It's your favorite math teacher, and today we are going to be starting in on topic 7 on linear patterns and functions, starting with block 1, which is kind of an overview of the types of things we're going to be learning about in this topic. So let's start off. As you can see on the left-hand side of the screen, it says, in everyday life, you will find many situations in which two quantities are related. Sometimes you can understand the relationship right away. Let's play the animation to see an example. Medium cheese pizzas cost $7. Additional toppings for the pizza cost 50 cents each. What is the relationship between the number of toppings you order and the total price of the pizza? So let's restart our animation here. Oh, there's the pizza oven. Okay, well, let's go and see what happens when we add more toppings. So we can see a table here and a graph. The price of the pizza is $7. We're going to drag a topping onto the pizza and watch what happens to the table and the graph when you add one topping. Here we go. Going to add some pepperoni. Oh yeah, there we go. As you can see, as we add one topping, the cost of the pizza goes up. Now the price of the pizza is $7.50. We can drag another topping on here to see what happens to the table and the graph. It looks like some mushrooms there. Two toppings, it goes up again to $8, and you can see it in the graph as well. And our last topping, let's see, this looks like green peppers. Oh yeah, gotta have some green peppers on there. That's going to be a tasty pizza. Now the price of the pizza is $8.50. So, as you can see, 0 toppings, $7, 1 topping, $7.50, 2 toppings, $8, 3 toppings, $8.50. And as you can see in the graph, it goes along the same lines. 0 toppings was $7. 1 topping, $7.50. 2 toppings, $8. 3 toppings, $8.50. All right. I'll turn the page here. In the pizza animation, you saw that the price of the pizza increased along with the number of toppings. So every time you added a topping, the price of the pizza went up. Each time you add a topping, you add 50 cents to the price. These pizza data follow a linear pattern. Linear data show a pattern of constant addition, indicating a constant rate of change. When you graph linear data, the points lie on a line, a straight line. In the table of data, you can see the constant rate of change. As the number of toppings went up, the cost would also go up by the same amount every time. 50 cents per topping. The graph of the data sets the points that fall on a straight line. If we were to connect all of these dots, they would lie on a nice straight line. So let's go over to the right side of our screen now, and let's see, it says, what pattern is shown by linear data? Well, let's take a look and go back and see. It says here, linear data show a pattern of constant addition, indicating a constant rate of change. So that's exactly what we are going to put down in our page here. Whoops, that didn't work out so well. Hold on a second. Okay, well, we got that straightened out. So what pattern is shown by linear data? Linear data show a pattern of constant addition, indicating a constant rate of change. And then the second question asks, when you graph linear data, the points lie on a what? What do they lie on? Well, this says here on the left-hand side, when you graph linear data, the points lie on a line. So, when you graph linear data, the points lie on a line. Okay, there you have it. They lie on a line. All right. So let's go to our next page here on the left. Linear patterns can be described in a number of ways that make them easier to understand. You can describe linear patterns using words. One topping is $7.50, two toppings is $8. Numbers in tables, 0 toppings, $7, one topping, $7.50, two toppings, $8, three toppings, $8.50. Graphics, here's our graph. It shows the same representation that we saw in the table. 0 toppings, $7, one topping, $7.50, two toppings, $8, three toppings, $8.50. And also with algebra, P equals $7 plus 50 cents multiplied by T, where P is the price of the pizza and T represents the number of toppings. The relationship between the price of a pizza and the number of toppings on it is an example of a function. In a function, each input value is linked to one unique output value. You've already studied relationships that were functions in previous grades. Now we're going to use this animation to see the types of relationships that are functions. Now, before we do that, let's take a look at answering question 3, because I think the answer to question 3 is here. Question 3 asks, or says, explain a function in terms of input and output. And this says, in a function, each input value is linked to one unique output value. So I think, why don't I just take this, and I'm going to copy that. I'm going to put it right here. Oops, and I'll get rid of this extra stuff. Hold on a second. I'm not sure I like that. Hold on. Okay, there we have it. In a function, each input value is linked to one unique output value. So when you put an input in, you get an output out from the function. Okay. A vending machine is like a function. When you push a certain button, you get out one type of drink. For example, one button gives you a sports drink, a different button will give you bottled water. There's our sports drink. And there's bottled water. It's amazing. You can choose the button that you push, but the kind of drink you get depends on which button you push. The set of button types is the set of values for the independent variable, and the set of drink types is the set of values for the dependent variables. So you push a different button, you get a different drink. And yet again. So, let's take a moment and answer the question for what is an independent variable and a dependent variable before we move on any further. So, an independent variable, I have a really great definition for you. Just one moment. All right, there we have. An independent variable is in a functional relationship determines what happens to another variable in the relationship. It is the input variable in a functional relationship. It's the value that's going in to the function. And dependent variable is a dependent variable in a functional relationship changes its value when the value of the independent variable is changed. It is the output variable in a functional relationship. So, when the independent variable changes, the dependent variable will also change. So, it depends on what you put in for the independent variable. Okay? Now, question number 5 asks, what were the independent and dependent variables in the context of the vending machine? Well, we have an answer for that. The code is the independent variable illustrated by the vending machine. The code that you press determines what type of beverage you get from the machine. And the beverage type is the dependent variable illustrated by the vending machine. The type of beverage you get from the machine depends on the button that you press for the particular code. All right, well, let's go back and take a look at the situation on the left-hand side of our screen. A function machine can help you understand the concept of a function. When you input a number into the function machine, you get an output number. For example, the cost of a pizza is a function of the number of toppings. So you put 0 in the input-output machine, and out comes $7. You put a 1 into the input-output machine, the function machine, and out comes $7.50. You put a 2 into the function machine, and out comes $8. And 3 goes in, and you guessed it, $8.50 comes out. A function is a way of linking every input value to exactly one output value. In this case, each number of toppings is linked to exactly one price. Every input has exactly one output. Okay. A table like this one is a great way to determine the cost of your pizza. In other situations, you can make predictions and answer questions more easily using other representations like a graph or an algebraic representation of the function. When these situations are linear, you can use characteristics of linear patterns to build an algebraic representation. A function rule is an equation that models the data. In this topic, you're going to learn how to identify functions, learn how to build linear functions, and learn how those function rules are connected to concrete numerical and graphical representations of the same linear patterns and data. All right, now, moving forward, let me give you a little preview of what you need to finish up in your pages over here on the right, as well as in your forms document. Question number 6 says, describe how a parking meter represents a functional relationship. Now you'll have to remember what the definition for functional relationship is, and then you'll identify the independent and dependent variables. For question 7, the table, which you'll see as I scroll down, this table here, shows the amount of water in a pool as it is being drained. Graph the data. Is this an example of data that follows a linear pattern? Explain how you know. So make sure you're answering these questions in your book because you will need to answer them in the forms document. Question number 8 says to identify the dependent and independent variables in the context of draining the pool. Now, something I want you to remember, that when you are creating graphs of data, typically this down here at the bottom on the horizontal is always your independent variable. Okay. And it's not letting me write for some reason. Is your independent data, and on the vertical is your dependent. Often the independent variable is denoted by X, most commonly, and the dependent is denoted by the Y on the vertical. So when you create your graphs, make sure that you put your independent variable across the bottom of your graph and your dependent variable on the vertical side of your graph. Okay? So in the pool water situation, which is the independent and which is the dependent? Question number 9 says, an ice cream parlor sells milkshakes in various sizes. An 8-ounce milkshake costs $3.50, 12-ounce milkshake costs $4.50, and a 20-ounce milkshake costs $5.50. Is this an example of data that follow a linear pattern. Explain how you know. I would recommend graphing the data and seeing if it follows the linear pattern. And then again, identify the dependent and independent variables in the context of buying milkshakes. Good luck, have fun with it, and I'll see you in class when we will discuss these questions. Have a great day, and don't forget to be awesome.